So in the previous video, we have learned how to accept the string, how to display the length of the string, and now we have to display whatever the string we have entered from the keyboard that we have to display on our console. So in the previous two videos, we have seen how to enter the string with the help of this toss interrupt and how we can display the length of the string with the help of this 0 to h interrupt. Now in this video, we will learn how to write the code for displaying the string. So here we have written the part of our code that is displaying the string. So first line of our code is dispm3, that is the call of our micro, that is we have written in our program. So whenever we are calling this M3 with the help of this disp micro, that time whatever the value is stored in that M3 variable, that is display string, will be assigned to the parameter that is XX parameter. And then with the help of this three line of our code, the display string message will be printed on our console. So we have to call this 09h DOS interrupt for printing the message on our console. Now you can check the next part of our code, that is load effective address si comma string 1 plus 2. So whatever your string 1 plus 2, that is the third byte of our message. So the third byte of our message, that is string variable, will be ABCD. And what is the memory location? That is 1022. So this 1022 will be loaded in our SI register because we are writing this load effective address. So whatever the address of their string 1 variable, that we are loading in our SI register. Now we are copying this L1 into our CL register. So in the previous code, we have copied the contents of L1, that is the length of the string is equal to 4. So now here, after writing this move CL comma L1, we are writing here CL is equal to 4, that is 04H. Now this is the part of our label. So what is this label and what we can do? This is your label, that is back one label. And this label will be executed till this jump not 0, that is JNZ back one instruction. So what this instruction can do? It will be executed till your 0 flag value is equal to 0. So when it will be 0 and when it will be 1, whenever you have to display the string, that is A, B, C, D, you are printing this character one by one on our console. When all characters will be printed on our console successfully, then you are going to the end of the string. And end of the string will be indicated as a /0, or else it will be indicated as a $sign. So whenever it will be goes to the $sign on our end of the string, your 0 flag will becomes 1. And that time it will not redirect to the back one, it will redirect to the next line of our code, that is our exit label. And with the help of .exit statement, our program will be terminated successfully. So in that .exit label, we are closing our data segment, stack segment, and code segment of our program. And with the help of end, that is the end of our program. So in that manner, our program will be executed. So here we can see how this label back one will be executed. So check the contents of first line of our code, that is move dl comma si. So whenever I am writing this move dl comma si, that time they are taking the values from that si location. So the contents of our si location is 1022. So I am writing here move dl comma in bracket 1022. So whenever we are writing that statement, that is move dl comma 1022. So on that 1022 location, we are pointing here string one of 2 value, and it consists of A, B, C, D. So this is the location 1022, and it will point to the character that is A. On that 1023 location, we will point this B. 1024th location, we will point this value C. And on that 1025 location, we are pointing that value D. And on that 1026 location, we are pointing that value the other side. That is the end of that string. So see here that I have written as well. So suppose we are pointing on that 1022 location. So on that 1022 location, our value of our character is A. But whenever we are considering it as a console, it will consider the value that is 61. That is the ASCII value of our variable A. Because in our register, we are storing the ASCII value of our character. So here, whenever we are taking the value that is move DL, 1022, it will take the value 61. And the 61 will be loaded in our DL register. Now, with the help of integer 21h interrupt and move h, 02h line, we are printing the data that is stored on our DL register. So now our DL register consists of value 61. So I am writing here DL is equal to 61. So whatever the value is stored in our DL register, that will be printed on our console, and they are taking the value from that DL register. And with the help of this 02H DOS interrupt, the data will be displayed on our console. So now our console can display the variable A. Accordingly, same as we have to display all these character, that is B, C, D. So currently we are pointing at our 1022 location. Now we will redirect to the 1023 location. So how this value will be incremented? That's why we have to increment this SI by 1. So after writing this increment SI instruction, our value of SI will be updated by 1023 because it is incremented by 1. So now our SI consists of 1023. Then we have to decrement our CL register. So currently our value of CL is equal to 04. After decrementation, it will become 03. Now we have to check that jump not 0, it will goes to the back 1 label. So whenever we have the value that is stored in our string, that is A, B, C, D, till that our 0 flag will be 0. So here our 0 flag will be 0. So it will jump to the back 1 label. Again, we have to execute this loop, that is move DL, SI, then this move DH, 02H, integer 21H. So whenever I am writing this, again, move DL, SI, then we have to take the location, that is move DL, 1023, because this value of SI will be incremented here, and now it will become move DL, we are taking the ASCII value of our B. So what is the ASCII value for our B is 62. So whatever the contents are there in our DL register, that will be printed with the help of this 02H DOS interrupt. So this is the 02H DOS interrupt, and that are calling in our H register, and with the help of integer 21H, we are printing the value B on our console. So now B will be printed on our console. Now again we have to increment this SI. So the first of all, we are pointing to the 1022 location, and we have incremented our SI by 1. Then we are pointing to the location B. Again we have to increment this location, and it will become 1023. And now we are pointing to the variable C. So this is the character C we are pointing here. And again, we have to decrement the value of CL by 2. That is 03 will be replaced with 02, because previously the contents of CL is equal to 03. Now after decrement instruction, it will become 02. So now what is the next instruction? JNZ back 1. So here also our 0 flag value is equal to 0. Then again we will redirect to the back 1 label. So again this group of statement will be executed. That is move DL comma SI. So whenever I am writing this move DL comma SI, then it will take the memory location that is stored in our SI. So we are writing here move DL comma 1023. And in that 1023 location, our variable is, our character is C. And the ASCII value for our C is 63. So now DL consists of value 63. So here with the help of this 02H DOS interrupt, we are printing the contents of our DL into our console. So our DL consists of value 63, that is the ASCII value of our C. So C will be printed on our console. The next part of our code is we have to increment the SI and we have to decrement the value of our CL register. So our SI is previously 1023. So after incrementation, it will be updated and it will become 1024. And our value of CL will be decremented by 1. So previously it is 02 and now after decrementation it will become 01. So now our SI will be pointed to the 1024 location, that is on that D character. So check here what is the next line of our code, that is JNZ back 1 label. So here also we have to check the value of our 0 flag. So our string consists of still one character, that is D. So if our string consists of the characters, then the 0 flag value will be 0. So here again we are moving to the back 1 label because 0 flag will be 0 and whatever the contents are there inside the label back 1, that will be executed again. So the contents are move DL comma SI. So after writing this move DL comma SI, we are taking the address of our SI will be 1024. And on that 1024 location, the contents are D. And ASCII value for D is 64. So that data will be loaded in our DL register. And with the help of this move H, 02H DOS interrupt and integer 21H, our D will be printed on our console. Now again we have to increment the SI and we have to decrement the CL register. So whenever I am writing here increment SI, our SI value will be updated and it will become 1025. And our DL register will be, our CL register will be decremented by 1. And previously the value of CL will be 01. Now it will become 00. So see here our CL register will be 00. And now we are pointing to the SI location, that is 1025. And in that 1025 location there is a dollar string, that is end of the string. So dollar indicates that end of our string. Whenever we are going to the end of our string, our 0 flag will be set to 1. So here we have to check that what is the next instruction. So our next instruction is jump not 0, then go to back 1 label. Now currently our 0 flag value is equal to 1. Then we are not redirecting to the back 1 label. It will jump out to the next line of our code, that is exit label. And in that exit label, we have written this dot exit and we are closing our data segment, code segment and stack segment. And with the help of end of the program, we are terminating our program. So this part of code we have seen in this video. that is written for displaying the string on our console. So by using this code, we are successfully display this A, B, C, D string on our console. So the output contents will be display string is equal to A, B, C, D. In the next video, we will see how this program will be executed in our emulator screen. So you can check the link in the description box.